So motivated the apply family in a bunch of different ways, right? We've talked about how it avoids for loops, how it works very well in a functional programming language like R. So let's apply this. So here's our situation. We want to perform operations on some structured data. That might be a list of lists, it might be a matrix or something like that. So our code here, we want to type apply, or as we'll see, some letter and the word apply. And then depending on which type of apply function it is, there are either 2 arguments or 3 arguments. And the usual structure for it, and of course this is very general, we'll deviate from this a little bit, as we'll see when we look at the code in a moment. We'll accept some kind of array, whether that's a vector or a matrix. For the function apply specifically, if that argument that we input is a matrix, then the margin input will give us an opportunity to say whether we want to work over rows with the number 1, over columns with the number 2, or we could even ask it for both rows and columns by concatenating 1 and 2. Or if somehow you have your the names of your dimensions listed, if your columns have names, if you've already attached it in a data frame or something like that, it can actually accept the names of those columns without you needing to type in a number to indicate what exactly you're looking for. And finally, of course, we've mentioned that this is a functional in this case, so it works on functions, and so fun is what we use to abbreviate the function to be applied. One thing that we might need to understand a little bit better, just from looking at this in a very basic setup, we need to understand the data structure and know which apply function we need to be using. So are we inputting a vector? Are we inputting a matrix? How does that change what we are trying to accomplish and which apply function we want to use? If I wasn't standing here right now and you were in R and you were looking to learn things about the apply function, you might type question mark apply. That would be what you would do if you were sitting at home on your laptop. And so let's take a look at what happens when we do that. So here are our help pages that come up when we type that. And as we can see, there are a couple of functions that are related to apply that come up as well that aren't maybe in the apply family in the sense that they don't have apply in the name. But it does look like not only do we have apply, but we have this E apply, L apply, M apply, R apply, and T apply. And actually, there are 2 other applies that are under L apply. There's an S apply and a V apply. So what I'm going to do in my talk today is I'm going to focus on the functions that specifically use the word apply in them. Just to be able to distinguish between all of them, so perhaps you don't have to look it up, you can just know it the next time that you go to write your code. So that's what we're going to focus on today is what kind of examples would we see if we were to click on this apply and see what happens. One other thing to note about this page before I move on, you'll notice that all of these are in the base package of R. There's not a special package that you need to download in order to use this, although I will mention later that there is sort of an extended apply library available as a package. We'll get to that later. So I'll move on to my R Markdown file now. Oh, but this is legible from a distance. I'm going to do the best I can not to just talk directly through it, because I certainly I'm not here to read to you guys. I want to show you something. So the first thing that we're going to do together is we are going to just create some fake data. And because we want to focus on what kind of data each apply function accepts as an input, I want to go through these couple lines of code very carefully. Normally we would just simulate some data and say, okay, here we have a matrix, this is what we're going to use. But I want to take a little bit of time to go through this very carefully. So I've just created a little bit of data in 3 different vectors: data 1, data 2, and data 3. And you can see that data 1 has the first 10 positive integers, data 2 has the next 10, and data 3 has the 10 following that. Then I have data vec 1. We're going to operate on data vec 1 a lot today. So data vec1 is something that's very specific. It is a list of data 1, data 2, and data 3. So what does it look like when we ask the console to print data vec1? You'll notice that it shows up as the 3 different lists. So we use a list function here. What would have happened if we'd have used the C function here? It would have given us a big, long, concatenated 30 vector. But here we're using the list function. So instead what happened is we got the first list, the second list, and the third list. If we had used a C here, by the way, and we'd asked R to tell us what the length of data vec1 was, it would have told us that it was 30. One interesting thing to note about the structure of data vec1, because it's a list, is it knows that it has 3 lists. So when you ask it that, it tells you that the length is 3. So there's some nuancy things about the structure here, and this is why I just want to go over it extremely carefully. So we got data 1, data 2, data 3, and we put them together as a list called data vec1. The next thing that I did as I was creating the data was I have this data L vector, L for the letters. So the letters function, I believe it's available in the base package. I didn't have to pull anything in to accept that. And what the letters function does is it will pull off the letters by their index in the alphabet. So when I ask it for letters 1 through 10, it will pull out A, B, C, D, E, F, G, H, I, J in that order. So then data vec2, which we will operate on sometimes as well, is a list of data 1, data 2. So remember, this is 1 through 10, 11 through 20, and data L, which is our letters. So what does it look like when we ask the console to print data vec2? It'll be 3 lists again, with 1 through 10 in the first list, 11 through 20 in the second list, and then these characters A through J in the third list. So what's the difference between data vec1 and data vec2? Data vec2, his third list is this list of 10 characters. So let's see. Next we want to, there's a page break there, I'm sorry. Data full is what I called the first 30 positive integers. So in a list, so I could have really called C data 1, data 2, data 3 if I had wanted to. Page break. There we go. And what I asked it to do was create a data matrix, which I called data mat. And I just want it to be a matrix with 6 rows for data full. So what this does is it prints out for us a 6 by 5 matrix of the first 30 positive integers arranged by column. So again, I imagine that most of the talks that you've ever been to in your life, you didn't claw through what the data was that carefully, but it's going to become very important for us as we work through this apply family of functions. So I just wanted to talk very carefully through all those. And again, if you need me to go back at any point and reference what those, what each of those data pieces are, just let me know and we can scroll back up in the code. All right, so the first function that we want to learn about, because it's the first in alphabetical order, is the apply function itself. So what does apply do? If you were going to the help pages, it would tell you that it returns a vector or array or a list of values obtained by applying a function to margins of an array or a matrix. All right, so we know that the apply function needs a matrix, and we're going to tell it this is our margin. We're going to operate on either a row or a column, right? Or perhaps both if we call C12. And remember, we could also, if we had named these columns, we can type in the names of those and it will accept that. And finally, we need a function. I just called on the mean function, which of course is in the base package. We're statisticians, right? So we look at these means all the time. So if I use the apply function on data mat, what is going to happen? If we put in the 1, you'll see that it prints out a row vector of 13, 14, 15, 16, 17, 18. So what exactly has that done? We know that a 1 means rows, right? So what it's done is it has printed out a 6 vector because there are 6 rows in our data matrix. And so what it's done is it's printed out the average of each of those rows. I constructed this matrix in a very special way, right? So that it hopefully is readily apparent, more or less, that this third column is the row average. So I hope that's not a surprise to you that when I ask it to give me the mean of the rows in datamat, it went through and it found the values that are actually located down the third column. Of course, it didn't just read those, it just happened, it computed it and it happened to equal that. I've again set that up on purpose. If we ask it for a 2 instead, what does that do? That means it's going to operate on the columns now. So you see that we're only reported 5 numbers this time instead of 6. Why is that? Because we have 5 columns, right? So we've acted on the columns, and what we've done is taken an average down each one of the 5 columns. So again, I set this matrix up on purpose so that it was easy to calculate what the column averages were, and it should be the numbers that are right in between, or the 0.5 markers, or the midpoint of all of the indices in the 3rd and 4th rows, right? So again, I tried to set this up so that it would be obvious that the mean of the first column was 3.5, the mean of the final column is 27.5, and so on. Of course, this is a very basic example. If you were to do this now, there's actually a newer and faster function out there that will do this for us. You've perhaps used it before, row means and call means, where the M in means is capitalized. So if you were to call those two functions, you'll notice you'll get exactly the same thing. If you were to perform a bake-off between these two things that I just introduced, row means and call means would beat it. It's a newer function, it's a faster function. But then again, who says that you're always going to want the mean? We're statisticians, we are interested in the mean often, so there was a special function created to do that, but who's to say that we had to use the mean here? Perhaps what I could do instead of using the mean, I'll just define my own function inside here. Let's say I define the function x plus 1. Again, we're trying to use things that are fairly obvious. Here I wanted to go down by column or whatever, but I'm not doing anything special here. It would have given me the same thing if I'd gone by row, because all I'm doing is adding 1 to each entry in the matrix. So again, we'll see now the positive integers 2 through 31 listed in our new data matrix. So there's a little bit about the apply function itself. Let's learn about the rest of the family. The next one in alphabetical order is eApply. The E in eApply stands for environment. And essentially what this does for you is it says, what if you need to use the apply function in a different environment than the one that you're in? There are a couple of these instances where I have to explain a little bit of what's going on in the code in case you want to look at this document later. Here's a little bit of my thought process. In addition to, I want to give this talk in the most insightful way, of course, but in addition to that, I need the R Markdown file to compile in order to be able to present it, right? So unfortunately, I can't present it in a way that it actually generates the errors that I would like for you to see. Or in this case, everything had to be in the same environment for it to actually compile, right? So in most cases, if you were to just type lapply on these guys, what you would find is that this doesn't work. Again, I had to stick it all in the same environment, so it actually does work there. But of course, when you assign everything, or all these guys, to a new environment, what happens is we'll simply ask for R to go over to that environment and find the mean of everything that's in there. So what all did I throw in the new environment? The first vector, E1, was the positive integers between 1 and 20. E2 was the next 20 positive integers, and E3 the next 3 positive integers. So again, setting that up so that it would be readily available that these were the means that we were after in this case. So you got 3 different lists in there, and what the eApply function does is it goes over to your other environment and it computes all those means for you. So there's the eApply function. And now it's time for Hadley-Wickham's first functional, the lapply function. This is the list apply, and that's what the L stands for here. It tells you in the help documents that it returns a list of the same length as x, each element of which is the result of applying the function to the corresponding element of x. So if you think about data vec1, you remember what that was. It was the list of those, it was the 3 different lists of the 10 positive integers. So I ask it to give me the sum of all of those, and this is really at the heart of the apply function. What does this do? It goes in and takes the sum across all of those lists. And so that's what the lapply function does. There are two offshoots to the lapply function that I want to talk about. Those are called sapply and vapply. I'm not sure what the S in sapply stands for. I imagine that it's something like simple. The reason because of that is that it's a user-friendly version and a wrapper, if you will, of apply. So really what this is it's a special version of lapply that instead of returning something in this list format, which if you're familiar with some R, you know that it might take a little bit of extra coding with all those $signs and stuff to extract these numbers. What sapply does, again, notice that we've accepted the same arguments here. All we've done is throw in data vec1, and we've asked it to compute the mean this time. And what it does is it gives us those means from before. So again, notice that that's just the sums divided by 10 because there are 10 entries in there. We're taking the average this time. So what it does is it returns these guys as its own little vector, which is much nicer for extracting these elements. So that's why it's a little bit more friendly to maybe a user that's newer to R.